Okay, almost at the end of binomials, we're going to look at calculations now. These you could use in a calculator, no problem yourself, but the whole point is if you're asked to use binomial, you have to do it. The segment notation, if we remind ourselves, if you see A0, A1 plus all the way to AN, it means that you could have started at your value of R being 0 all up to N and add them together. You've seen that in standard deviation, we've been using it as well. So remember that you can have that notation there. Remember that we have starting from R is 0 up to R being worth N, and remember that that means the total sum of, okay? So when you're using this, which you have done already, then you'll know that it means that you're collecting each term up the way to NN of the binomial coefficients, and you know how the powers are going up and down respectively. Right, and so let's just go for this. So if you've seen x plus y to the 5, you know it would be 5r, you know it start at 5 and go down the way, and you know that progressively go up to 5. The sigma means that you add, so all the way from 0 up to n, okay? So you know that it would go like that, and you would get your answer. That's easy for you. What we're going to do is use that process, but with numbers. So we're going to do it in calculations now. So without a calculator as well. The binomial theorem can be used to find powers of a real number. We'll call it Z. It doesn't have to have any special letter, but we're just calling it that to say we're going to split it into two parts. So we're going to call it X and Y. Whatever the number Z is, X will be the closest integer and Y will be what's left over. So I'll give you some examples of that. If you had 1.9, you wouldn't go to 1 plus 0.9. You would say, okay, let's start at 2 and take off 0.1. So that's the X and that's the Y part. If you have 3.11, you'd have 3 and you'd add on 0.11. If you had 6.98, you wouldn't start at 6. You would go to 7 and take 0.02 off and so forth, okay? So let's do a question. We'll do 2 and then you can try. So using the binomial theorem, find 1.04 to the 3. I would hope you'd think about it being 1 plus 0.04. So the only difference is to the power of 3 means that we look at it like that. So let's do it. 1.04 to the 3 can be 1 plus 0.04 to the 3, and because it's to the power of 3, you know that it goes between 0 and 3. You'll have your coefficient. 1 will be to the power of 3, 2, 1, 0, and so forth. So the 1 actually just is 1 then, isn't it? Which is nice. So if you have the coefficients, you'll have 3, 0, 3, 1, 3, 2, 3, 3. 1 will be 1 to the power of 3, 2, 1, 0, which is just 1 in each case. And you'll get 0.04 to the 0, to the 1, to the 2, to the 3. It's just the same as what you have been doing, except you get numbers. And you know that you have your Pascal's triangle. So you've got 1, 3, 3, 1. 1 to the power of anything is just 1. So it's just this part here. So that to the power of 0 is 1. This to the power of 1 is just 0.04 squared. Right, 4 fours are 16. If you know that a half times a half is a quarter, 0.0.5 is 0.25, you collect the decimals. So we would have 4 decimal places when we go to open that up. When you have to the 4, 4 times 4, 16 times 4, 64. And if you do that 3 consecutive times, you end up with 6 decimal places. So I'm just emphasizing that before I put that down. So this will be 0.000064, okay? When you go to collect, it's actually not difficult. You have 3 times 4 is 12. So 3 times 0.04 is 0.12. 3 16s are 48, so you just have the same number of decimal places, and that's just one of those. I've used colour to emphasise I have at no point used a calculator here. The first entry is 1, and then you have, after the decimal, I've used green, so you can see that you've just got a 1. Then I've used kind of lilac, so you've only got a 2, then darker blue, you've got a 4. Actually, they all go together really nicely because of the decimal positions, and you don't have to think about it. I didn't use a calculator once there, okay? Let's try it with a small number, 0.7. How would you express that? 1 take 0.3, I would hope you'd have in your head. If it's to the power of 4, it'll be 4r, won't it? And now let's go and do it all over again. So same idea, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. You'll have 1 to the 4, 3, 2, 1, 0. And then minus 0.3 to the 0, 1, 2, 3, 4. Just the same as before. Okay, we know with Pascal's triangle that you've got 1, 4, 6, 4, 1. And 1 to the power of anything is 1. So it's just the last part. Anything to the power of 0 is 1. Then we will have minus. Watch your signs here, because when you square this one, it will go to 0.09. Watch your decimal places. You will create 3 decimal places. It will be negative, minus 0.027, and that will turn positive with 4 decimal places, and you'll get a. This is not that difficult. You'll have 1 minus 1.2 plus 0.54, and you can do a sum at the side for 4 times 27 if you need to. And what have I done? I've used different colours this time to emphasise to you that you could, still without a calculator, collect the positives. So you've got 1.5481 because of the decimal position, and collect the negatives, and you've got minus 1.308. That's not that bad. If you take 1 off of both, you can see that. You could take 3 off the 5, you could take 8 off the 8. So quite quickly, you've got 0.2401 without a calculator. Isn't that great? Okay, there's not many for you to try. It does come up occasionally in exams, but you have to use the expansion. You could go to 19 in the Scholar, but this is the only questions that I'm giving you. So you could check your answer using the calculator, okay? After that, we'll do extension after all of this, but you're going to just revise everything. So you've got your review exercise of finding coefficients, expanding and knowing the rules. Answers are on page 241. You have advanced review with trickier negatives and fractions for expanding and finding terms. The term independent of x means x to the 0, okay? And then we have the set review exercise, and this is the exact same question as presented before, just wordy in expansion to the 7. What value of r should be in the general formula to find the coefficient x6 to the 10? It just means the same. Find the coefficient for that, find me r, find me the number. And then after that, these two, the set reviews, the answers are on the website, but if you want to, you can just find the answer to 117 using your calculator. You may prefer just to go by the list and work through it steadily and slowly yourself. So if you want, at the final part of the PDF, you've got the review, the advanced set, and the tasks involved. Okay, so that's that. I'll just go back and show you all the questions that you're going to do, so you can use the PDF, which they're all there, but you'll need to open that to check your answers anyway. And that's the end of binomial calculations.